Thank you very much for coming to this talk. I know you had a choice and you intentionally picked this one, so I'm very grateful for you, and I hope you won't regret it, because I'd like to share some performance tips about how we can speed up our application using the tool that not everyone knows. It's called AT&T Video Optimizer, and I'll let you know how to play with that for a while. Right, so first a little bit about me. My name is Bartosz Kraszewski. I came here from Białystok, and normally I'm a software engineer focused mostly on Android applications, and I work at a company called Software Hut. But that's enough about me. That's enough. Let's just now talk about someone much more important, about you. So I assume you are here Android developers, so please raise your hand if you are Android developer. And a quick question, do we have iOS or web developers here? Anyone here? Very good. Because the truth is, even that presentation is called about Android, the tips I'll be talking about also apply to different technologies. Okay. Now, first of all, let's just focus why performance matters, because sometimes our managers seems to don't care. Looks like applications only require features, much more features delivered as fast as possible, and nobody cares about that. But next time you are going to have an argument with a management about the feature versus performance, I can give you a few arguments how to win this debate. Because I got kind of cool facts that you can use in this argument. For example, there's a fact, it's based on a research, that experiencing a mobile content delay actually increases user heart rate by 38%. And increased heart rate is very cool if you are exercising, but during your day-to-day activities, it's not very cool, because it's basically a level of a stress. And if you, just think about it, you as a developers have actually the influence on your users' health. And if your users are stressed and they have heart issues, they may eventually die, and you won't get any money from that, right? We want to get some money from our users, and we can't do it from a dead person. And there's another funny fact, because about 4% of users actually damage their phone due to a slow application performance. So let's do small math. I see about like 30, 40 people here. That means we got at least one person who did it. So please raise your hand if you are one of those. Very good. That's a very calm audience, so no one is going to throw anything at me. That's very good. But again, that means that we as developers, we have influence on a person's budget. If some nervous guy keep destroying his phone, he eventually run out of money, and we want to use this money to buy our product. Ericsson was interested about this stress level comparison, and based on their research, that experiencing mobile content is almost equal as stressful as solving difficult math problems, as standing on top of a virtual cliff. So you can think about it, how stressful it is, and watching horror movies. So again, as a developers, we serve to our users experiences similar to watching horror movie. Not a very good idea every day. And what can user do if application is slow or experiences constant delays? There's a big chance they are going to remove application, uninstall it, so we just lost customer, and we get a negative feedback. That's it, so that's a bad review. But there's one good thing, that about 15% of users are still going to use our application, even if it's slow or it performs not very good. Okay, but we want everyone, the 100% of our heavily hard-acquired customer base, right? But as a developers, so at some point we decide, all right, we need to optimize something because we love to optimize. That's one of the most fun tasks. But the problem is that human brain is not very good to deal with optimization because we look at the code, and if we don't have enough experience, we are just guessing which part are too slow. Without measuring, we just look at the code and, yeah, that function is ugly. I think it takes a lot of time. For example, sorry for showing you a Java code in a Kotlin world, but that's a good example. For example, here we are copying the array using the very fast native system function. But seriously, those are just 3 elements, so it doesn't even matter. We have to measure if that's actually the slow moment of our application. All right, so we have to now think, what's the optimal guide to optimize something? First of all, looks like it's don't do this, just write code that's simple and readable and don't bother too much. But when you're done, perform the testing. So we are looking for bottlenecks using tools. Machines are much better in counting, measuring, so you already know what's the performance of your code. And then, when you know what sections are very bad in your code, then you can just take up your sleeves and start working on optimizing. And the second part, so the making the performance tests, is actually the part of a presentation I want to be focused mostly. And to that, I'd like to introduce you to the tool. It's called AT&T Video Optimizer. Not everyone heard about it, but it's a desktop application that you can download on the AT&T developer website. And it would allow you to test your application against the industry best practices. It was developed by AT&T, so they care about mobile apps, not use as much data as possible, because that will reduce their cost. But we can also benefit from that by just making sure that our application is very good. It's available both for Android and iOS, so we can also test iOS application with that, but I don't have experience with that, so I'm going to focus on Android part. The desktop application is available for Windows and Mac, and it's free and open source, so we don't have to bother our managers with additional costs. What's important that this tool is mostly focused on testing the network performance, so our connectivity layer. The way we are making requests to the server, it allows us to test in a different scenarios, because normally in an office we have really fast Wi-Fi, even that we have LTE, so we are not even sure how our application works when our customer is somewhere in Bieszczady, and this could be a very slow place to get his feet right, and we may not even know that. So with this tool we can test network status that is compared to 2G, that we are losing a lot of packages, and so on. And also, when the network layer is working hard, the battery drain is significant. So we are focused on the network part, and also how do we care with the battery. And it's important if user is out of office, somewhere abroad, he needs to make sure that application is not costing his too much money, and also not draining his battery. And how it actually works. In my first version draft of this presentation, I prepared video, but the user interface is so big and complicated, it looks terrible on video. So I like to replace it with a simple diagram. Because we install a desktop application on our computer, we connect to cable to a phone. Technically, you can use simulator, but I have really bad experience with that, so please use actual phone. And what's really important, it's better to be some sort of testing phone, because other applications are making the network noise that may interrupt your testing session. Because on your phone is going to be installed AT&T app called Arrow, so Application Resource Optimizer Collector. It's responsible for listing all processes that are working and running on your machine, on your phone, and it's tracing you when the session starts. Because then, when we install your application, in this moment, applications start to trace and monitor its behavior, how much CPU it uses, how much network it uses. And about connectivity to internet, the VPN connection is going to be created, and all the network packages have to go through the collector that will eventually analyze it and display to you in form of report. Okay. So to sum up, you just have to install the desktop version, start your testing session. One testing session should be about 20 minutes of normal using. So you just have to log in, register, just browse the feed. Typical stuff users do. And what's also cool, it's really good if you remember to test your application in idle mode. That means just keep the phone lying, doing nothing. Maybe you have some background calls. It's also important to test if you're not draining battery when phone is totally useless. And at the end of the testing, the report will be generated. So that's actually a cool metric because it's accountable, right? Report is about some, I think, like 30 sections grouped into categories. It's file download, it's security issues, and when you run the test, you see how many tests you failed, because each test has a best practice related to it, so information reading, like a homework. So you failed this test, better read it, and information how to fix it. I briefly wanted to talk about basically everything because I find it fascinating, but I didn't think we have a time, so I just chosen a few sections I'd like to introduce to you. And another fun aspect, I'm not sure if you know this website. We have a site called HTTP status cats, because that's just a list of HTTP status codes explained with a cats. And this is how I learned the meaning of every status code. So I think, maybe it's a good idea to try to teach someone with using cats. So I picked a few sections from a testing report and explained it with a cats. So let's see how it works. Right? He's very smart. So the first thing I like to talk about, and you are likely to fail in your application, because the tool is going to test if you are using the zipping and text file compression, because texts are very well compressible. Zipping is a fast operation, and if the text file is bigger than 850 bytes, then you will just benefit from this operation. And today we have in our endpoints web services in a JSON format, in XML. Those are just text that compress very well. Also, we can display images in SVG that are downloaded from server. SVG also compress very well. But PNG files, for example, not very well. And if you know that you failed this test, what have you do to fix it? First of all, it needs to be configured on a server, so talk to your backend guy, so please enable it. And inside your HTTP client, you need to add additional header that's called accept encoding, and use the gzip format. You can have, for example, HTTP interceptor in your OK HTTP client. There's another potential problem related to duplicated content, because the tool, when you are using the testing session, it's going to monitor every file that you download, and if it spots that some of this content is duplicated, so it's downloaded not necessarily, it will be listed and flagged, so you can actually see how your caching mechanism works. Because normally, if you download some script, static text, image from server, it's a good idea to make sure that headers are set properly and the file gets cached on a disk. And if nothing changed, just use the file copy. You may see, well, what's the big deal? The images are small sometimes, so how much we can save? The tool in this report will tell you exactly how much you can save. And also you can know how much transmission speed would be saved if the image will be served from a file cache. And remember that there are still people that are paying for the cellular connection. They don't use data plans. So, and people use our applications abroad in a roaming. So think about those people and make sure our caching works very well. Okay. Also, we have sometimes applications that are very rich for images. So it's everywhere, Snapchat, Instagram. So we are probably working on something like that. But screen size is limited. Even if it's HD or slightly bigger, sometimes image that is served, it's much, much bigger. And all this space, first of all, the memory gets wasted because we don't need to keep such a big image in memory. And remember that it's not only about client-side resize, because we can also get from a server image that is actually smaller. The tool is going to check all the images that you load and that you display, and will get information what's the size of its image container. If the image is bigger than 150% than its container, you'll fail the test. And how we can deal with that? We need to remember that, especially for thumbnails and avatars, we have to prepare another resource that is much smaller. And also, it's common for image serving services to use parameters called sometimes size or width. And so we are asking for a picture in a specific size. So for that, it's not a big deal. You don't have to make it pixel perfect, so count every image container. You can specify like 3 thresholds for a small, medium, and a large device. And then download images in those ranges. The application is mostly focused on a network, so it's going to monitor your connections, and it's going to monitor it very hard, so you may fail those tests. And the problem is that we could make the server connections that are too distinct from each other. This point depends on application. Of course, if it's browsing some huge catalog, there is no chance to cache everything. But if we could, there's a chance that we can download as much data upfront and make sure that our API calls are made in a specific tight windows. The ideal moment is at the very launch of your application. We make all calls that are possible, trying to even maybe predict where user goes. And then application works in a kind of offline mode. But why is that so? We need to remember how the mobile radio works. Because it's basically a state machine working in 3 states. And by default, the mobile radio that connects to internet is not using any power. It's an idle mode. It's not doing anything. But when the data is needed, it switches into the high performance mode when its energy consumption is really high. it stays in this state while downloading data, but after 5 seconds of idle, it switches to the semi-state that's in between. In this moment, some energy is consumed. It's ready to come back to a high-performance state again, but basically waits. And then, if it's no longer needed, it comes back to the idle mode. So knowing that, the application will test your requests and print a pretty report with a timeline when you actually made these calls. It's explained here. So let's take a look, for this example, at these first 2 calls. They are separated by lots of seconds, and that means that RCC state here changed 3 times every time. But we could actually make it a little smarter and tie those connections together, so they are all in the just one state. The additional change of state is not required. What's really cool that during this 20-minute session, AT&T Video Optimizer will tell you how much exactly energy in joules you could save by making those requests better. But here we can see that it's still not perfect. It's not in one state. We can do better, and I'll talk about it later. Because, again, about these grouping connections, I'm not sure if you are watching the Android developers videos, and they are really cool on YouTube. I recommend that. And they mentioned, they call it a big cookie model, because they compare requests to cookies, and they ask you to, as a developers, to get as much data as possible in a small window of time, instead of making lots of small requests. To do so, you can prefer, of course, offline first. So the application once have the data cached is working in a very offline mode. But also, we can not make requests when, for example, we enter one page, but we are asking server to be notified when the new content is for you. So in this case, we are not asking. So we are not asking for data, but we know when data is pushed. Okay. And there's one more problem with closing connections, because what we normally do when we it's use pattern that's used in HTTP clients sometimes, that the single connection is getting reused. That means I open connections, I download the data with lots of endpoints, 1, 2, 3, again, and I keep it open in case someone wants to ask for another endpoint. In this case, it will be a little bit faster because the connection does not have to be set again. But if we control when we are opening and closing our connection window, we can do a little bit better, because let's see at the graph. See, those are our requests. They're perfectly fine grouped. We made a really good job with grouping our connections. But there's this ugly blue spot that's asking our RC state to work again, and we are wasting energy. What is it? That's the actually connection timeout. That's information from server that, hi, you are not doing anything here, what's happening? And instead, if you are in control and you know that, okay, I'm done with downloading data so far, you have to close the connection. Because each time we leave this connection orphaned like that, the energy will be wasted, and AT&T Video Optimizer will tell you exactly how much in joules energy was wasted. There are also some images, best practices, because, for example, you may serve data from server that contains metadata. And to be honest, metadata are kind of, for normal user, they're kind of useless and slowing down like those balloons on a cat, right? So unless it's a photography app and you really want to show with which camera it was taken, on what was the exposition, and if it was modified with a Photoshop, you can consider removing that on a server, of course. Because while making a testing session, the application will count the size of metadata and will show you exactly how much text information was wasted. And based on numbers, it's your decision. You take this could be hundreds or just the numbers of kilobytes, and it's your decision. You want to serve it or maybe remove it and make sure it's just a little bit faster. What else we can do? The AT&T Video Optimizer will take a look at the image compression rate you are using. For example, it will list files that use compression higher than 90%, and will prepare a second picture with 80% of compression and 70% compression. By normal eye, I'm not such a very good, I don't have a good eye for a detail, but I'm sure for most of users, it's not a big difference between 90 and 70%. But the savings of in a weight could be, its file could be twice as small, with absolutely no difference for an image eye. And also, the JPEG and the other file formats was invented long time ago. That's the true. And the computer science went even further. So we have now much more efficient file systems to serve images. We got a WebP on Android. We have a JPEG 2000. So we may also consider using the more modern compression algorithms, right? So application will list and just give you information that, hey, by using this format, you may also save some data here. And data saved is always a good idea. There's more. What else we can test? Because, for example, there are some security tips. Application will test if you are using HTTPS or HTTP. Also, will test if you are not exposing private information like a login, password, or email with a non-encrypted connection. You will also know that the cipher you are using in your encryptions, if they are safe, if they are big enough. Because it's very low-level network transmission they are checking, so they are able to let you know that, hey, maybe you can do a little bit better in this section. Also, why exactly the tool is called Video Optimizer? Before the name of it, it was just a AT&T Arrow, so it was Application Resource Optimizer, but with a new update, the testing report got, I think, like a 10 points related just for a video, and I think they are so proud about it, so they even renamed and rebrand the product. But the truth is, I never have to test video in my application, but if you stream some video, I think you should totally test it, because those are really best practices that could use for streaming videos. And during the testing, what you got is a testing report that can be saved to PDF that telling you what tests you failed and not. And you will also see a lot of debug data that you can see. So during the testing, the CPU state, for example, or GPS state is going to be recorded. And that's a really cool idea because, for example, if you are in a building, a big concrete building, there's a huge chance that GPS won't work there. And you will see on a graph what was the state. If it's trying to connect very hard, it's also using a lot of energy. But we can save this energy. So you can, for example, check that if I got no success with GPS connection, maybe I'm not in a best place to use it, so let's just defer it for later. You will also see the CPU usage and the temperature. And you may see, well, I already have it in Android Studio, so what's the big deal? And I'll tell you what's the big deal in a very next slide. But with that, you'll also see the network state. So if you are the Wi-Fi or cellular and you got a lots of low-level data, I'm not even so. I never even get so deep because it was information about the packets and all that transmission data. If someone is really into the networking layer, he may find a lot of good time spending and analyzing those reports. And if you are using wake logs, it's also important to check because application will list and show you what time you acquire a wake log, and maybe you kept it for too long or forget to release it. And that's actually the diagnostic tab. As I mentioned, it doesn't look very good on the slides. That's why I deferred it to pretty much end. But we can already see here that during the session, the RC state was, for example, RC is the mobile radio. So during the whole testing, the radio was on. We'll see what was the network throughput, what was the CPU usage, and other information. But the benefit over the Android Studio is that during the testing session, the video is recorded. So you can always come back to this testing. For example, check 12 minutes, and you will see that a lot of CPU usage was made in this moment. And in Android Studio, you just see the peak, but you are not really sure what happened there. For example, I was testing different applications. I was having fun with Twitter, and I noticed that browsing feed is kind of a cheap operation. Not much happened here. But then I wanted to make a new tweet, and the network layer just exploded. A lot of information was sent. So I believe probably Twitter really want to know what is the background of me creating a tweet, right? So what's happened here? A lot of precious data is being sent there. And I could see it on video that when the new tweet screen appeared, basically the network state exploded. And to sum up, we as a developers have a really big influence of user health, wallet, and the well-being. And we can use a tool that gives us good metric, because when we start from failing 12 tests to failing just one or anyone, we actually see our progress and we can demonstrate to our managers. And as a result, at the end, our user heart rate is going to be better. Thank you very much.
So what do you think? What is the best practice of use this tool, like during development, every sprint, on the end of...
Sorry, what's the best practice of developing?
To use this tool during development.
I think you shouldn't consider it too much during the development. I think it's more like for use if your product is already mature and people use it. That will help you improve it even better. Because when starting a project, you just think about the maybe the offline first approach or caching. But I think the most benefits are if you have some working already a solution and you are looking for tweaks to improve it even better.
My question is a bit of a meta question, but with all these tracking tools, usually they come with some cost as well, and especially you're saying that it's recording video and everything else. Mm-hmm. Out of curiosity, have you actually have you measured the impact of this tool? So, to give you an example, why I'm asking, there's a lot of analytics tools, and there's sending a lot of analytics, but on top of them, like the tool itself is sending quite a bit. It's generating stuff. So I just wonder how these results might be skewed by the tool itself.
I don't think it should be skewed by itself, but you might have a problem, for example, if you're trying to test just your application, but for example, even Android system is sending some data in the background. And because it's encrypted through HTTPS, you are not sure, for example, if this closed connection was because of your application or people from Google actually screwed up. And it happens a lot.
Do you know if retrofit closes connection?
Retrofit. It depends on, actually it's not, retrofit, it's not managing it. The OK HTTP client, and you have to specify by default, I think it uses connection pool that will be timed out.
Okay.
So you have to create something like a wrapper that will, if you know when you are done with downloading, just keep the connection done. So you have to little bit work on the OK HTTP client. Okay, if that's all, thank you very much again.